So here is another example on how we can use the concept of the binomial theorem. The problem says write the first three terms in the expansion of x minus 7 to the 19. So here, if you look at the exponent, it's already 19. So the Pascal's triangle might not be the most practical method that we have to use, because that means you have to create the triangle until you reach the set of numbers needed for n equals 19. Okay, so, and take note, we're not expanding we're not expanding this until we get all the terms. We just need the first three terms. Okay, so the best option is to use the binomial theorem. Okay, so here, so the first term in the binomial expansion of x minus 7 to the 19 is n, so 19, 0, the first term raised to 19 minus 0, and then the second term negative 7 to the 0. Okay, so that's the first term. And then the second term will be 19, 1, x to the 19 minus 1, negative 7 to the 1. And the third term is the n, 19, 2, x to the 19 minus 2, negative 7, then squared. So this is the first, the second, and the third. You simplify these three terms and you're done, right? Okay, so 19, 0, we already know that it's 1. Okay, if this is 0, it's 1. Okay, so that means the first term is, let's write that down. First term, 19, 0 is 1. So this is 1. X to the 19 minus 0 is x to the 19. This is also 1. So first term is x to the 19. 19, 1 is 19. Okay, so the second term is 19. And then x to the 18, negative 7 to the 1 is still negative 7. But you have to multiply 19 and negative 7. So that will give you negative 133. So the second term is negative 133 to x to the 18. And finally, the third term, 19, 2. So you can use a calculator to find the combination. 19, 2. So 19 combination 2 is equal to 171. So third term is 171. Then x to the 17. Then negative 7 squared is 49. Then you have 49 and 171. Just multiply the numbers. So you will have 8379 x to the 17. So when you expand the x minus 7 to the 19, so we are expecting, so x to the 19 minus 133 x to the 18, and then plus 8379 x to the 17, then plus and so on. But the first three terms are x to the 19, negative 133 x to the 18, and 8379 x to the 17. So see, it's very helpful to use a binomial theorem when the exponent is already large and you just want to find some few terms. You're not expanding the binomial until you get the last term. Okay, so let me work on another example. So just to extend the idea, let's say I have so this is example B, 2 plus 9x squared to the 12, and then we still want to find the first three terms. So first term will be n is 12, 0, first is 2, then 12 minus 0 is 12, and then the second term is 9x squared to the 0. The second term is 12, 1, you have 2 to the 11, then 9x squared to the 1, and then the third term is 12, 2, and then 2 to the 10, and you have 9x squared to the second. Then what you need to do is just simplify each term. So again, this is 1, this is 1, so you have 2 to the 12, 2 to the 12 is 4096, so that's the first term. This is 12 times 2 to the 11 times 9 to the 1, which is 9. So 12 times 2 to the 11 times 9. So, okay, so 12 times 2 raised to 11, and then times 9, it should be 221184. And x squared raised to 1 is x squared, so that's the second term. And then 12, 2, so 12 combination 2 is 66 times 2 raised to 10 is equal to 67584. So I'm working on my calculator here, and then you have 9 squared, so times 81, and you should have 5474304. X to the 2 times 2 is 4. So first term, second term, third term. Okay, so you can just list them. So 4096, 221, 184 x squared, and 5474304 x to the 4. The first, the second, and the third term. Okay, so these are the first three terms of the expansion. Okay, so that's how you do it. So you see, the binomial theorem is a more practical method in expanding or finding a term in an expansion, as compared to the Pascal's triangles when the exponent becomes bigger already. Okay, so that's it. Oh, let me add more examples so that we can maximize this video. Okay, another example would be just finding a specific term. Say, I want to find the 12th term of x plus 1 to the 17. Okay, so basically, so our n is 17, so 17, so 12th term, so my r should be 11, it's always 1 less than the indicated term. And then the first term is x to the 6, that is 17 minus 11, and then times 1 to the 11. Okay, so this is the 12th term. If you simplify this will be 17 combination 11, so that should be 212376 x to the 6. Now 1 to the 11 is 1, so this times 1. So basically this is 12376 x to the 6. You see, you're just looking for a single term, the 12th term, so just apply the binomial theorem. Okay, one more example, this time with a minus sign. Say I have x, or 2 minus x, let's reverse the number in x, to the 23. Let's say I still want to find the 12th term. Okay, so again, so look for the n is 23, the r, so I'm looking for the 12, so r must be equal to 1 less than the term, so 12 terms are 11, and then the first is 2, so you have the exponent is the difference of 23 and 11, and that's 12, and then you have minus x, so this is negative x raised to the r, which is 11. Okay, so this will be the 12th term. So again, we look for the value of 23 combination 11. So just use your calculator to find that. So you have, so this will be 1352078. Now we need to look for 2 raised to 12. So this is equal to 4096. The negative x to the 11, so this is an odd exponent, so the negative will remain negative. Then the x will take the exponent 11. So you have this number times a negative 1. So 1352078 times 4096 should be equal to, so it's a very big number, so 5538111,488. The negative x to the 11 will be, so negative the number, then x to the 11. Okay, so through the binomial theorem, we were able to find the 12th term of the expansion. Okay, so some important note on this, when you're working with the minus sign, so make sure that you include the minus sign. Okay, so that's how I use the binomial theorem. So we have seen a lot of examples already, like find the first 3 terms of an expansion, and we had some finding just a single term. So they all have the same idea. Okay, they use a binomial theorem to find those terms. Okay, that's it.